Okay, so it's a quick introduction to Arduinos. So we are going to be blinking an LED using internal timers of an Arduino UNO microcontroller. So our circuit is going to look as follows. We are going to hook an Arduino through a 220 ohm resistor in series with an LED. So maybe before I jump to the code, I just want to share with you a background and some brief understanding of an Arduino. So an Arduino is a microcontroller that is powered by Atmel AVR Atmega 328P. So if you can see this, this is an external power supply port where you connect to about 9.5 volts maximum, which can be converted here up to 225 up to 25 volts by these solid state power converters here. And this section, or this port, this side is power. You can see it has got input output reference, it has got the reset, the 3.3 volts usually used for sensors, to power sensors. Then it has got a 5 volts, it has got the ground there and another ground, and the V in. So V in is where you tap in power that you have supplied using this external power supply port. So you tap it from the V in, then you send it onto your breadboard, especially if you are running high current devices like a motor. You tap from here, then you take it onto the rail on the breadboard. Then this section here, it's an analog section. Pretty much deals with analog parameters like sensor values. If, for instance, you're collecting the values of oxygen from an oxygen sensor, it will come into here because they are analog continuous values. All right. Then when you come on the other side here, you find that you have got this section here. This section is a digital section which deals with power width modulation, and also we have got this section here. This one is analog input expander. So when you want to hook up a number of sensors to this particular Arduino Uno, you'd need to incorporate what we call a 12 IC input output expander here, so that you can hook up a number of sensors. Then in a case where you want to hook up a number of control devices or devices to be controlled a lot more than these pins we have here, if you can see there are just 14 of them, you'd need to use these pins you're seeing here, the ICSP2, to control to connect your expander here, so that now you can have more means of connection. Okay, so now if we try and talk about the code, or maybe before we go on to talk about the code, this button you see here, it's a reset button. If you loaded the program into the ROM, you can be able to reset it by means of pressing this button. Or in a case where you run into an error after you programmed your microcontroller, you can try to get out of the error loop by pressing this reset button with varied delays of time press. And this is a USB standard 2.0 you use to program your microcontroller. Then this is an IC that just controls the power and the solid state converters here. Then the RX and the TX, these are LED bulbs here, or LEDs that powers on when you're programming a microcontroller. This shows you that your microcontroller is on, the on LED there. Okay, so now let's try and understand the code that you're going to use to program our LED. So we have connected, because this LED needs just very low current, and as the electrical principle, in order for the current to be drawn, there should be some form of resistance or resistivity in the circuit, or resistance in the circuit rather. So we introduce this resistor to act as a pull-up resistor, external pull-up resistor, and also to act as a current limiter, or a current limiting device in this circuitry. And after you do that, your live will come into the 220 ohm resistor into the anode side of the LED and coming out of the cathode and grounded to the GND there. So if we look at the code there, you understand that let me just try and make it more reasonable. Okay, so if you look at the code here, you see that it's a turning on of an LED for every 1 second and turning it off for at least 1 second, and this will repeat. So when you say int pin LED 9, this actually looks wrong with what we have on our breadboard. Let's just check that again so that we are just sure. Okay, it's correct. This is also linked to pin 9. If you can see, this is pin 8 starting point, pin 9, 10, and so on. So okay, it's all right. So if we get back to our code here, you find that int pin LED 9. So when you say pin LED 9, pin LED equal to 9, what this actually means is that the pin where you have connected your LED, this name just represents this 9. If you want, you can call this pin LED 9, but in the program you can just be using 9 itself as a number. But to make your program readable, this is why you use descriptive names like this. So this is on the declaration section. Now in the void setup, when you say void, you're calling a function. So in a void setup, so we have a setup function. This function runs once. So here is where you initialize your program. So you say pin mode, pin LED output. So you're saying that this pin is actually an output pin. You're giving it the direction, this pin. So this is just going to run once. Now, under the loop function, when you say void loop, you're calling the function loop, and it's going to run repetitively because it's a loop. And this is where you're going to put your code that to be running repetitively. So if you see this simple code, which you're relying on the internal timers, we are saying digital write, pin LED high. So at this point, when you say digital write, it means that you're providing current to that pin. You're writing to it. You're providing current to it. You're sending a signal to it. That's what digital write means. If you're dealing with a button, you're going to say digital read. You're collecting the signal from it. That's what that means. So in this case, we are saying digital write pin LED, high. What this actually means is that you're providing current to the pin LED or to pin 9. And this is so much so that this LED can turn on. And it is so easy because we have got the external pull-up resistor. As soon as that current is provided, as soon as we set this high, it will try and pull the current, try to make it high and all that stuff. So we are going to provide a delay of 1000 because a computer understands milliseconds, or in this Arduino, or in our C++, or this microcontroller we are dealing with understands in milliseconds. So when we say 1000, we actually mean 1 second, because 1000 times 1 milli, that just cancels the milli and remains us with a second. So we do that. So it will be on for 1 second. Then after that line of code is executed, remember it's sequential, then it's going to come to digital write pin LED low. So this turns it off for the same time 1 second. And this will keep on alternating, keep on repeating until the power is just turned off from the microcontroller. So this is basically how we can actually write that code. Okay, that's how we can write that code. So we end there for now.